Hello friends and my dear students. Today I am going to discuss about Bernoulli's equation. Okay, it is a part of differential equation. So let's begin this topic. The topic is Bernoulli's equation. Okay. Now, the form of Bernoulli equation is dy upon dx plus py equals to q y raised to the power n, where n is not equals to 0, 1. Okay, and p and q are functions of x only. So this is what Bernoulli's differential equation. Now, what happens if n is 0? Like if n is 0, then equation becomes what? Dy upon dx plus py equals to q. Because n is 0, so y raised to the power 0 is 1. So this is the Bernoulli equation reduces to this. This is nothing but it is a form of what? Linear differential equation. So if n is 0, then Bernoulli equation reduces to linear differential equation. Linear differential equation. Okay. So what happens when n becomes 1? So if n is 1, then the equation becomes dy upon dx plus py equals to qy. Okay, this is reduces to dy upon dx equals to qy minus py, which is q minus p, because q and p are function of x only. So I take y as common. This is nothing but variable separable form of the differential equation. So what it becomes? A variable separable differential equation. Variable separable differential equation, because you can separate the variable terms on either side. Take all the y containing terms including the differential coefficients to one side and all the x containing terms on the other side. That is why this equation becomes what? Variable separable differential equation. So Bernoulli's equation is nothing but dy by dx plus py equals to q y raised to the power n, where n is not equal to 0, 1. If n is 0, then it becomes linear differential equation, and if n is 1, then it becomes variable separable differential equation form. Okay. Now, the next part is how to solve this Bernoulli's differential equation, because every differential equation has its own solution. Now we can reduce this Bernoulli's differential equation into linear differential equation by suitable substitutions. So I am reducing this as, first I write the whole term, that is dy by dx plus py equals to q y raised to the power n. Divide y raised to the power n in the above equation. In the above equation. Okay, so in the above equation, so the equation becomes y raised to the power minus n dy by dx plus p y raised to the power 1 minus n equals to q. Okay, let's suppose this is equation number 1. Now substitute or put y raised to the power 1 minus n equals to, let's suppose, t. Okay, so now differentiate this y raised to the power 1 minus n equals to t with respect to x. So differentiation of y raised to the power 1 minus n with respect to x equals to differentiation of t with respect to x. This becomes 1 minus n y raised to the power minus n dy by dx equals to dt by dx. So I get the value of y raised to the power minus n dy by dx as 1 upon 1 minus n into dt by dx. Okay, so substitute this value in equation number 1. You will get 1 upon 1 minus n into dt by dx plus p, and you already assume that y raised to the power 1 minus n equals to t, so it becomes pt equals to what? Q. Multiply 1 minus n to this equation, you will get dt by dx plus p into 1 minus n into t equals to q into 1 minus n. So this is nothing but a linear differential equation form. It is what? A linear differential equation. Linear differential equation in x and t. The variables are in x and t. So now we all know the solutions of the linear differential equation. The solution of above Bernoulli equation, which is reduced to this one, the solution of above Bernoulli's equation is t into integrating factor equals to integration of integrating factor into q into 1 minus n dx. Now what is integrating factor? This is the solution. Okay, where t is what? We put t as y raised to the power 1 minus n, and integrating factor is nothing but e raised to the power integral p into 1 minus n dx. Okay, so this is our integrating factor. I think the solution of this Bernoulli's equation is clear to all. Okay, if you have any doubt about the solution, you may ask or comment. Now I am taking an example of this Bernoulli equation. Okay, so I am taking an example over here. The example is y log x minus 1 into y dx equals to x dy. Now try to reduce this form. Try to reduce this form into the Bernoulli's equation form. It becomes y log x, y square log x minus y equals to x dy by dx. Okay, so in the next step it becomes x dy by dx plus y equals to y square log x. Now I think this is what the differential equation, Bernoulli differential equation is look like. If you divide x in this equation, you will get Bernoulli's equation. Okay, so divide this equation by x. So divide above equation by x y square as well. Okay, so what this equation look like after dividing it? It may becomes y raised to the power minus 2 dy by dx plus 1 upon x into y raised to the power minus 1 equals to log x. The equation becomes like this. Now over here you have to substitute y raised to the power minus 1 as t. Differentiate again with respect to x. You will get y raised to the power minus 2 with a negative sign dy by dx equals to dt by dx. Now what it look like to be, it is y raised to the power minus 2 dy by dx equals to minus of dt upon dx. Now substitute the y raised to the power minus 1 equals to t and y raised to the power minus 2 dy by dx equals to minus dt by dx in this equation. In this equation you will get minus dt by dx, you will get minus of dt by dx plus 1 upon x into t equals to log x. Okay, so I think I made a mistake when I divide. Wait a minute. Yeah, so divide it by x. Okay, so now it is quite good. So divide it by x over here. Okay, so now try to make it in the form of linear differential equation. You will get dt upon dx plus minus of 1 upon x into t equals to minus of log x upon x. This is the whole thing that we have. Okay, now this is what a linear differential equation look like. Now the solution of this equation, is t multiply integrating factor equals to integration of integrating factor into this term minus of log x upon x dx. So I am calculating the value of integrating factor over here. Integrating factor is nothing but e raised to the power integral p dx, and what is p? P is this value. So it look like to be integral minus of 1 upon x dx. So it becomes e raised to the power minus of log x. Take this negative sign in the power of x, you will get e raised to the power log of 1 by x. So the integrating factor becomes 1 upon x. So this is the overall integrating factor that look likes to be t into 1 upon x equals to integration of 1 upon x into let I take a negative sign out of the integral factor, so it becomes log x upon x dx. Okay, so what is the value of t that we substitute? We substitute t as y raised to the power minus 1. Okay, so put the value of t over here. It becomes 1 upon xy. It is minus of x raised to the power minus 2 log x dx. Now apply integration by parts in this form. Okay, so over here I am differentiating the log x term and integrating x raised to the power minus 2. So log x as it is, take log x as it is, integral x raised to the power minus 2 dx minus big integration like x raised to the power minus 2 dx multiply differentiation of the term log x, differentiation of the term log x and again dx. Let this equation look like. Okay, now if you simplify the whole term, you will get, if you simplify the whole term, you will get minus of log x upon x minus of 1 upon x. Okay, so you will get this minus of log x upon x, and from this term you will get minus of 1 upon x plus a constant of integration, let's suppose it be c. Okay, so now the equation becomes 1 upon xy 1 plus log x by x plus c. So this is what the overall solution of the given differential Bernoulli's equation. Okay, so I hope that you all enjoyed this question and the concept of Bernoulli's equation. If you have any doubt, you can comment. Please subscribe, like and share this video. Hope you will enjoy this lecture. So bye bye to all and God bless you.